Smart Child Zone presents Limits and Calculations. If f of x is a polynomial and a is a real number, then the limit of f x as x approaches a equals the value of f x at x equals a. Evaluate the limit. The function minus 5x plus 6 is a polynomial. So you can compute its limit as x approaches 1 by evaluating the function at 1. Evaluate the limit. The function minus 6t plus 3 is a polynomial. So you can compute its limit as x approaches minus 7 by evaluating the function minus 7. Evaluate the limit. The function 7x minus 7 is a polynomial. So you can compute its limit as x approaches minus 5 by evaluating the function minus 5. Evaluate the limit. To evaluate the limit of a rational function at infinity, we divide both the numerator and the denominator of the function by the highest power of x of the denominator. We divide both the numerator and the denominator of the function by the highest power of x of the denominator. Evaluate the limit by expanding the numerator. First, see if the limit law for division can be used to evaluate the limit. And find the limit of the denominator. Since the limit of the denominator is 0, the limit law for division cannot be used. Now find the limit of the numerator. Since the limits of the numerator and denominator are both 0, try to find expressions to cancel. The numerator is a complicated expression and can be simplified. Start by expanding the numerator. You can cancel t, because as t tends to 0, t is never equal to 0. So t over t equals 1. Now try to evaluate the limit. Evaluate the limit by expanding the denominator. First, see if the limit law for division can be used to evaluate the limit. And find the limit of the denominator. Since the limits of the numerator and denominator are both 0, try to find expressions to cancel. The denominator is a complicated expression and can be simplified. Start by expanding the denominator. You can cancel x, because as x tends to 0, x is never equal to 0. So x over x equals 1. Now try to evaluate the limit. The absolute value function is a piecewise function. Evaluate the limit. To evaluate the limit, find the value 2 minus 7x approaches as x approaches 7 from the right. Evaluate the limit. The trigonometric functions sine and cosine have 4 important limit properties. You can use these properties to evaluate many limit problems involving the 6 basic trigonometric functions. Evaluate the limit. Because sec x equals 1 over cos x, you find that since sin 0 equals 0, both the numerator and denominator of sin x over 4x approach 0 as x does. So you cannot evaluate the limit directly. Rules for right-hand limits. Corresponding rules apply for right-hand limits. The graph shows f(x). The dashed line is a vertical asymptote. Choose the correct statement. The limit function has a raised minus sign after the 5. This means it is the left-hand limit of f(x) at 5. To find the limit, look at the values of f(x) as x approaches 5 from the left. So the limit equals infinity. These rules are used to determine end behaviors on graph. Use the graph of f(x) to find the limit. The dashed line is an asymptote. To find the limit, look at what happens to the graph of f(x) as x decreases without bound. The graph of f(x) approaches the horizontal asymptote y equals 8 as x decreases without bound. So the limit equals 8. Evaluate the limit. Evaluate the limit. To evaluate the limit, first evaluate the limits of -6 and t square individually. This shows the direction of the limit when the exponent is odd. And this shows when the exponent, n, is even. Choose the correct statement. Choose the correct statement. So the limit to the function is infinity. For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.